Well, you screwed it up, Faith, already. Okay, so number one's a gimme. We have several different types of numbers in the real number system. Remember, on one side in our graphic organizer, right, in our Venn diagram, we started with those counting numbers that my son can count. 1, 2, 3, 4. Those are called natural. Then we added one number, which was 0, 1, 2, 3, 4, which were called whole. Then we had integers, which were the whole numbers and their opposites. So 1, 2, 3, 4, -1, -2, -3, -4. Then we had rational numbers, which were any fractions, decimals that stopped, which were called terminating decimals, or we had decimals that were repeating, something like 2/3, which is 0.66666. We call that repetant. Okay? This says an irrational number. An irrational number is a decimal that goes on forever, that does not repeat. So, 3/17. Is this irrational? What type of number is 3/17? If it's a fraction, what type of number is 3/17? Come on, come on, come on. If you got to get something out, get it. If you got to look at the quiz like I've asked you to, get the quiz. I mean, you're only on video. I need a little bit of help here. So your options are natural, whole, integer, rational, or irrational. You've already told me this isn't irrational. Yep, get your stuff out. Good idea. Good idea. Go, go, go. You should have a set, that organizer. Hannah found it already. And if it's a fraction, what is it? Rational. The only choice for 3/17 is rational. So that does not tell me that it is irrational. Okay. How about -6? What type of number is -6? Yeah. It's an integer. Okay? The whole numbers and their opposites are integers, not irrational. What about the square root of 13? How would I check to see if the square root of 13 is irrational? You find the square root of it, and what happens if it's irrational? What would it be? Wouldn't stop. But as soon as you do a square root and you get a decimal, it is immediately irrational. So as soon as you take the square root of any number and it gives you a decimal, it is irrational. What mode does the calculator need to be in for it to be a square root that we want to use? Mine. Classic. Because, may I see your calculator real quick? Where's your pencil? There is a button on the back here of your calculator. If you look at the way bottom, it says reset. I've got to press that. And it says memory cleared. And if you just press that and then you pressed in the square root of 13, it's going to give you the square root of 13. It's not going to do anything. You've got to make sure that you go to mode and then go to classic. Okay? So, square root of 13 is a decimal. That's what makes it irrational, because it never ends. Give me a thumbs up if we got number one, because number one was supposed to be the gimme. I'm not seeing a lot of hands. Whew, okay. Maybe number two is the gimme then. Let's take a look. Okay. Let's just look at this. Kelly is buying pajamas for her 5 closest friends. Awkward, but okay. Using the graph shown below, how much money will it cost her if she decides to buy a 6th pair of pajamas for herself? This is what we're doing now. These are functions. Okay? So she buys 1 pair of pajamas. The cost is somewhere between 10 and 20. She buys 2 pairs. The cost is about 25. 3 pairs. The cost is almost 40. 4 pairs might be 55 pairs, in between 60 and 70. What type of function does this appear that it will be? What's happening with those points? It's going to be linear. Very good, Bailey. So this is where I would get a ruler, and I would continue my points. Everybody still with me? I got it. Here you go. Okay. We know that we're trying to find 6 pairs of pajamas. Does everybody see how I'm finding where 6 is and it matches up with my cost? So that's somewhere between 70 and 80. Without doing a lot of actual number math, just knowing that it's a linear function because it appears to be a line, it's staying what? If it's linear, what's happening between these points? They're staying, it's a C word. Constant. Give me another word for constant. Consistent, give me another word. There's 2 really phrases that we really want to focus on. Slope, and another one that starts with R.
Rate.
Say it again. Rate of change. Constant. Slope, rate of change. They're staying consistent, they're staying the same. If from here to here stays the same, from here to here stays the same, from here to here, from here to here, from here to here has to stay the same. So we know that our answer should be between 70 and 80. Does everybody agree? Okay, well now let's look at our multiple choice. Is there one answer that's between 70 and 80? So which choice should it be?
B.
There it is. Give me a thumbs up if we got B. Ah, good. There's one of our gimmies. I love it, I love it, I love it. Okay. Again, these are straight from your map test. Last but not least, you guys actually had this question on an Illuminate test. And I don't want to say that you stunk at it, so I'm not going to, but I'll let you read between the lines. So what do you think happened, Maurice? Nah, it didn't go good. Okay. So it's telling us M is the slope, B is the y-intercept. We know y equals mx plus b. That's what it's asking you to write. It's asking you to write y equals mx plus b. M is my slope, b is my y-intercept. What's the easier thing to find immediately? Maurice, the y-intercept. So I go to my y-axis. It's intersecting here at positive 6. Have I lost anybody yet? Okay. Looking at this line, Zoe, is it going downhill or uphill? Downhill. If it's going downhill, does that mean my slope will be positive or negative? Negative. So now I have a negative slope, and we know that our slope is going to be a fraction. Okay. So now we're going to try to find another point. No, this one works. You see how that intersects perfectly? Everybody with me? Okay. So now we're counting rise divided by run. Up and down divided by left and right. Y's divided by x's. 1, 2, 3. So I have negative 3, 1, 2. Some of you, my guess, did this. And this isn't wrong. You did 1, 2, 3, 4, 5, 6. So you had m equaling negative 6 divided by 1, 2, 3, 4. How many of you had a final answer with negative 6 divided by 4? What's wrong with this fraction? Say it, Levi. It's not simplified. Remember, if you have a fraction, you have to simplify it. How do we simplify a fraction in the calculator? So everybody get your calculator right now. Do negative 6 divided by 4 and tell me what the decimal is using math language. Caitlin, what'd you get? Negative 1 and 5 tenths. What buttons do we press from there to get it back to a fraction? Maya. Press second, table, and enter. Now what do we have, Bailey? Negative 3 divided by 2. The calculator does the work for you. Do I wish that you could simplify this in your head? Absolutely. But that was a 7th grade topic, not so much an 8th grade. So if you don't know how to simplify it, let your calculator do the work. Questions? Did anybody get 2 out of these 3 correct? Raise your hand proud. Anybody get 3 of the 3 correct? Okay. So these are things to work on. Does this now help if you saw these questions again? I would hope so. Go ahead and get out your packets, please. Okay. We are trying to figure out whether something is linear. Do you have a packet? So this is page S37 maybe? 38. Nope. 30 what? 40. S40. Thank you, Maurice. So it's on page S40. So we are only talking today about linear functions and how to make those equations. If we're talking about linear functions, what's the equation every single time? What equation are we going to need, Maurice? Y equals mx plus b. Okay. To find out whether something is linear, we need to see if there is a constant, the slope, or the rate of change is the same. To do that, I take each set of numbers, because it's asking us which of these functions appear to be linear. To get from 2 to 4, what happened?
Doubled it.
We what?
You doubled it.
Or we added what? Because we're not going to double because we're going to do both sides. So what did we add?
You add 2.
Add 2. So when we're doing this, we're only talking about adding and subtracting. To go from 5 to 7, what did we add? Leah? 2. Okay. How about from 4 to 5? What did we add? How about from 7 to 8? Okay. How about from 5 to 8? 3. How about from 8 to 11? Yeah, 8 to 11. 3. Okay. So how can I check to see if this is linear? How do we find slope? What divided by what gives us slope? Leah. Y divided by x. So here we go. I'm going to take, because remember, inputs are my x's, outputs are my y's. So if you need to put that, go ahead. So now I have 2 divided by 2, which is 1. Does everybody agree? Remember, slope must be what C word? Constant. So if I do another one, 1 divided by 1, which is 1. Are those staying constant so far? So far, this appears to be linear because they're staying constant. The rate of change is staying the same. 3 divided by 3 is 1. Do those slopes stay constant? Okay? So this is linear. And if you had to explain, because the slopes are constant. Okay? I'm going to erase this, so make sure you have it. Everybody with me? Okay. Montana, you good, man? Everybody good? Bailey, you good? Okay. So I did that one. I'm good at math. That's kind of why I teach you. It's not just because I'm enjoying and you want to hear my voice all the time. It's an annoying voice. Faith has told me many times in her head, I can read your thoughts. So walk me through this. So you're going to walk me through this. What is input? What is output? Raise your hands. Tell me what the input is. Tell me what the output is. Go ahead.
Input's X.
Okay.
And output's Y.
Okay. Good. We're just trying to check to see if it's linear. So what do I need to do? Help me out. What should I be doing to see if it's linear? Go ahead.
See if the numbers how many you add to them.
Okay. So tell me what you want me to do with 2 and 3. I'm sorry, I couldn't hear you. Okay, so I'm adding 1. Do I do the other side or no? Okay. What's that side?
5.
Okay. So really I have 5 divided by 1. Everybody sees that? Because it's y divided by x, okay? Then what? Somebody else? What's my next thing that I'm going to do, Bailey? So I heard 3 and 4, then what? Okay. Okay. Right now I'm going to ask you the question. Is this staying constant? Why not? Yeah, because the numbers are changing. 5 divided by 1 is 5. 7 divided by 1 is 7. Right there, when we do our division like we did over here, we divided all of them, we got 1. The rate of change is not staying the same. So this is non-linear. And if you're like, Mr. H, I don't believe you. Cool. Add 1, add 9. This rate of change is staying the same, but this is not. So that is non-linear. Okay, the last one's on you. Go. So you're doing that last one all by yourself. You tell me if it's linear or non-linear and why. I would say for that middle one, it's non-linear because the rate of change is not staying the same. The slope is not constant. Can you erase this middle one? Okay. Mr. Miller, you did awesome, man. Walk me through this.
So 0 and 1 is +1, and -3 and 1 is +4.
Good. Now, I'm going to pause you there. What did you do underneath? Because I loved what you did. What did you do immediately? You had m equals?
M equals 4 over 1.
Whoa, what?
4 divided by 1.
Thank you. Which equaled?
4.
Good. Bless you, by the way. Sorry. Okay. Then what?
+1 is for 1 over 2, and +5 for 1/6.
Okay, then what'd you do?
M equals 6 divided by 1. M equals 6 divided by 5. 5 divided by 6. Divided by 1.
There you go. You're all right. You have it on your paper. Like, I know you have it on your paper. Do I need to keep going? Immediately, what's happening? Is the rate of change staying the same? No. So we're going to say non-linear. And if it says y, the rate of change is not the same. Thumbs up if we got that one. Okay. Questions so far? That's 41, I believe. Is that right? Okay. This is going to be the last problem that I do with you, and then you're going to get some time to practice with your group, okay? So, do you suspect the function is linear? Compute the rate of change of this data for at least 3 pairs of endpoints and the corresponding outpoints. Well, that's what we've been doing anyway. So how are we going to see if this is linear? Actually, here's what I want you to do. You see if it's linear. Go. So we're going to check to see if this is linear the same way. I would use Mr. Miller's method and make sure that somewhere I'm going to put m equals and then show that division. Okay? You're showing that division. You watch the video. Thank you. I'm sorry for this. If you look around, those people should know. You're just getting a review, which is awesome. I appreciate it. If I had food, I'd give you something, but I can give you a surprise. It's an O. Don't let anybody tell you that the pipe cleaner is a fuzzy neon glow stick, but for being the only person watching. There you go. You can make it into a bracelet. You can make it into like a crown. There's all kinds of things you can do there. Yeah, folks, fuzzy neon glow sticks. You don't get them. You know what? You know what to do. Okay, Caitlin, can you walk me through this one?
For the for 1 and 2, it's 1,
Good. For 1 and 2, you had +1.
and then for 2 and -1, 3,
Is it +3 or -3?
-3.
And that matters. Okay, that matters. Okay, so then let's stop right there. So I'm going to write m equals what, Caitlin?
-4 divided by
Which is -3. Okay, so my slope for that is -3. Great. Okay, let's do the next one.
2 and 4,
Which is
2, and then -1, -7, -6.
okay. So right now that kind of looks different, right? So you might be thinking, hey man, this is it's not linear, but we got to check. So go ahead. Eyes open if we want to be actually paying attention.
You do -6 divided by 2.
-6 divided by +2, which is -3. Okay, so far so good. But it asks for 3. So one more. Go ahead.
4 and 6 is 2. And -7, -13, -6.
Which is the same thing, which is -3. So, for letter A, is it linear? Is it linear, yes or no?
Yes.
Yes, because our rate of change is the same. Wonderful. Have I lost anybody there? Okay. What equation? Okay, wait a minute. Wait a minute. What's the only equation we're always going to use, Maurice? You're the one who's told me this. We know it's going to be y equals mx plus b. And I'm going to do b up here so that I have some room to work. Everybody with me? So I'm just going to kind of put it up here. So we know that we're doing y equals mx plus b. Do we have our m right now? We found it. This is the whole purpose of us checking to see if it's linear, was to see if we could find our slope. So now I have y equals -3x plus b. My y-intercept, x needs to be 0. Correct? Do we have a 0? Okay. So we need to find the b. Here's my question to you. Do I have an x and a y? Where? Yeah, the input and the output. Hannah, choose one of those. Choose one of those ordered pairs. 1 and 2. If this is my x, what do you think I can do, Hannah? Because you already. Where can I put this?
Put it in the equation.
You can put it in the equation. You know what it's called. It starts with an S.
Substitute.
There it is. Thank you. So now I have -3. She's substituting my x in plus b. What's going to go in for y? 2. So we are solving an equation. You're going to have to solve your equation for b. Minnie, I need you to keep your head up, honey. If you don't feel well, I can send you to the nurse, but I need you to keep your head up. So we're here. So now we have 2 equals -3 times 1 plus b. Can we solve for b? Okay, let's do that. So, equation, we're isolating b. I combine like terms on the same side. -3 times 1 is -3 plus b equals 2. How do I isolate my b? What do I do to move everything away from b, Maya?
Add 3 on both sides.
Add what?
3.
Add 3 to both sides. We're using the inverse operation, additive inverse. leaves me b equals 5. Okay. So I'm almost done. I've got my m and I've got my b. Those are the only two things we need for our equation. So the equation is now y equals negative 3x plus 5. Questions? Okay. Let's go to page S42. So we're now on the problem set. You are going to do number 1, number 2, number 3, number 4. So you may move around. You're doing numbers 1, 2, 3, and 4. You're going to work. We're going to go over these. So if you're watching the video, now would be the time to just start working. You can pause it, then you're going to have to skip ahead because there's going to be like 15 minutes of dead time. So you are going to do this one, do 3 and 4. So let's get started. Go.
Mr. H, are you able to move around?
You can move around, yes, sir. So you may work with people if you want. You're going to need calculators to be able to do this math. That will certainly help. Let me know if you need some help. I'll gladly come around. So if you need to go back to the notes, I've given you everything that you need to answer these questions. If you're like, I don't know what to do, then go back to the first 2 examples we did, because both of those will help you out. And give you about 12 minutes, get through as much as you can. This is the most quiet you guys. This class is ridiculously quiet. I want you working together. I want you to talk these through. So at this point, we should be getting very close to being done with at least number 1 and probably number 2. Going to go about 5 more minutes. I said 1, 2, 3, and 4, didn't I? I meant 1, 2, 3, and 5. I apologize. 1, 2, 3, and 5, not 4, 5. I apologize. You're doing 1, 2, 3, and 5, not 4. I apologize. What equation describes this function? So it needs to be y equals, it needs to be something with numbers. It has to describe this. Minnie, are you going to go through the rest of it? Okay. So I'll continue again. Got about 3 more minutes. You should absolutely get through 1 and 2. So then you're going to say a non-linear. So if there's no non-linear, you can say non-linear. That's all. Because we don't know how to find a non-linear equation. Yeah. You don't know enough math yet to do that. My algebra kid's good. You guys just don't know enough yet. Oh. One, 2, 3, 1, 2, 3. See what happens. But your way's not wrong, right? So that's fine to do, but there's an easier way. Okay, last minute. Try to get as far as you can. So if you did not finish, make sure that you're asking questions and writing down the answers. So if you did not finish, make sure you're asking questions and writing down the answers. Here we go. So let's go back to number 1, please. We've got the inputs and the outputs. Zoe, my inputs are which variable? My x, which means my outputs are my y's. So to get from 3 to 9, I add 6. 9 to 17, I also add 8. So my first one is y divided by x, but that's not simplified. Go into your calculator, do 8 divided by 6. Second table gives you 4/3 is your m. 9 to 12 is 3. 17 to 21 is 4. So that leaves me 4/3. So far, they're staying constant. 3, 4. That's the same. They're constant. My slope is 4/3. I've checked 3 of them. You see how I've checked 3 different points? So does the function appear to be linear? Yes, because our slope is staying constant. Letter B, find an equation. Okay, so the equation, I'm going to come over here, is y equals mx plus b. So we know it's y equals, we don't have m, we have m, we don't have b. Our m is 4/3. Have I lost anybody yet? But we've got a lot of x's and y's. So let's substitute them in. My y is 9. 4/3 times 3 is my x plus b. From here, we solve our equation. 4/3 times 3 is 4, plus b equals 9. I subtract 4 from both sides, b equals 5. So my equation for this particular function is y equals 4/3 x plus 5. Give me a thumbs up if we got that right. Okay, I know a couple of us did. A couple of us had a little bit of confusion going on. If the graph is, or if the function's linear, what will the graph look like? If the function's linear, what's the graph going to look like? A straight line. Yeah, it's going to be a straight line. Questions on number 1. Okay. Number 2. So again, there's my, oh, perfect. I did that wonderfully without even meaning to. I've got x and y's. Adding 1, subtracting 2. Adding 1, adding 2. Stop. You can stop right there. Are those slopes going to be the same? Is the rate of change going to be the same? Is -2 divided by 1 the same as 2 divided by 1? No. Is the function linear? No. Because -2 divided by 1, 2 divided by 1 is not the same thing. What equation describes the function? We don't know. This is a nonlinear function. So say it's nonlinear, so we don't know. You don't know how to make a quadratic equation. You don't know how to make a cubic function. You don't know how to do that yet. So if it's nonlinear, just say it's nonlinear, I don't know. We're almost done. Questions on number 2? Okay, number 3. So again, we're checking. I'm going to need your help. So this is 4/10, +4. Oh man, 9/10 and positive plus 9. And this is, oh man, 6/10 and it should be +6. So I need your help, but I think that it's going to be 10 or maybe 100. What's 4 divided by 4/10? Somebody help me. 10, okay. So my slope is 10. And that's going to stay the same for all of them. 9 divided by 9/10 is 10, and 6 divided by 6/10 is 10. So did all of my slopes stay constant? Yes? No? Maybe? Yes, they stayed constant. If they stayed constant, it's linear. So now find the linear equation. So again, y equals mx plus b. Can we see that? Yeah. So y equals, my m is 10, x plus b. We're searching for b, so we're going to substitute in my x and y. 2 equals 10 times 2/10 x, 10 times 2/10 plus b. 2 equals, I think that gives me 2, is that correct? Yes? 10 times 2/10 is 2, plus b, I subtract 2, b equals 0. Is b allowed to equal 0? Yeah, it just means the y-intercept is at the origin. So we've got y equals 10x, and that's it. You don't need to put plus 0, because y equals 10x. Last, but certainly not least, number 5. So number 5 says, is the following graph a linear function? Well, it appears to be a straight line. How would you determine if the slope is constant? So what would you do?
You could draw a straight line.
You could, yeah, you could draw a straight line, see if they're straight. I'd go even one less because I don't want to get a ruler. My rise is 1, my run is 1, 2, 3. My rise is 1, my run is 1, 2, 3. My rise is 1, my run is 1, 2, 3. Are my slopes constant? If they're constant, are they linear? Absolutely. So, I hope that you have a wonderful, safe spring break. Come back to me safely. When we come back, there is a video in Google Classroom for Lesson 7. Okay? You're going to need to watch Lesson 7. Then the next day, so you're going to come back on a Wednesday. That Friday, we have a quiz going over lessons 1 through 7. So, spring break, you need to watch lesson 7, even though we're having trouble watching those videos. Let's do that. Have a great day. Where's my mouse? I guess.